So the first question is, what is the rule for a translation where I say I need to go left 7 up 2? Well, you say take your XY and then you draw an arrow. That's the best arrow I could draw using the software. And then what do you do to the X? You move it to the left 7, so that'd be X minus 7. And then they want you to move it up 2, so that'd be Y plus 2. So this is how you could say, take every point and move it to the left 7 up 2. Okay, next, how does the rule take every point, move it 3 to the right, 5 down, move to figure? Well, I just said that. So you're going to move 3 units to the right, and then you're going to move 5 units down, and instead of using the word move, there's a fancier word. You could use the word translate. So next, I'm being asked to take the triangle ABC, and I went ahead and plotted the points A, B, C. Noticed I labeled them, and they want us to translate it using this rule. And this rule says move everything 4 units to the left and move everything 6 units up. So I'm going to start at A, and I'm going to go 4 units to the left. That's 4. And then 6 units up. 1, 2, 3, 4, 5, 6. So there's my new A. And then B, I also am going to go 4 units to the left, 6 up. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. And then C, 4 units to the left, 6 up. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Connect my dots. So A, move from this point to this point. B, move from this point to this point. And C, move from this point to that point. And then they should look about the same, which it looks like they are. And then it's important to label these points. So we're going to label this A prime, we're going to label this B prime, and we're going to label this C prime. So we notice that A went to A prime, B went to B prime, and C went to C prime. So we call this the image, and we call the red one the pre-image. Pre-image is where you start, image is where you end up. Now number 4, they want us to take this triangle and reflect it over the given parallel lines. Notice that there is not a coordinate graph. So I'm going to reflect it over here, and then they want me to take that same triangle and reflect it over here. So I'm going to first reflect it over this way. So first thing I'm going to do, I'm going to take this triangle, and I'm going to reflect it over this one, so it'd be just about right, and I have to kind of guess. There has to be the same amount of distance, and notice it is flipped over. It just kind of looks the same because it appears to be equilateral. And then once I flip that, once I take this triangle and I flip it over this line, then it's going to be somewhere approximately there. Let me just see if I agree. That's close, right? So I flipped it over here, reflected it, then I took it and reflected it over this parallel line. Alright, from there, they want us to reflect over the line y equals negative x. So the line y equals negative x would be the line, need a line, It starts in this corner. It goes to this corner. That's y equals negative x. So you're going to reflect it, and it's going to end up over here somewhere. Now, if you're like me and you like the rules, which I do, the rule for reflecting over y equals negative x is you negate the y and you put it here, and you negate the x and you put it here. So pretty much you take the x and the y, you swap them places, you change the signs. So for example, the point A, and I'll go ahead and label the points because I think that'll help us. The point A is 1, 2, 3, 4, 1, 2, 3. So this is 4, 3. So I'm going to pause this, and so from there, 4, 3. What do we do to get A prime? We take the 3 and the 4, we swap places, and we negate the sign. So that now becomes negative. That also becomes negative. So A is going to be at negative 3, negative 4. 1, 2, 3, 1, 2, 3, 4. So that's going to be A. And I'll go ahead and label that as A so I don't forget. So A went from here to there. And then D is 1, 5. So you're going to take the 5 and the 1, swap places, and then also negate it. So you're going to change that to negative and negative. So then D is going to be at negative 5, negative 1. So D went from here to here. M, you're going to take the negative 1 and 5, swap them. And then you negate them both. So the 5 is going to turn into negative, and the negative is going to turn into positive. So that's going to be negative 5, 1. And that would be the point M. And then the W, the 4 and the negative 1 swap places, and you negate it. So 4 is going to turn into negative, negative is going to turn into positive. So that'd be negative 4, 1. And that is where the image of W will go. And then from there, I can make my new shape. So I just found if I take this black image and then I reflect it over y equals negative x, this is what I end up with. So what if I asked you to reflect over the line y equals x? Well, that would be this way. And then what is the rule for that? You take your xy, and instead of negating it, all you do is swap them. So this is a little bit easier. You just take the x, move it to the y, take the y, move it to the x. That's what that rule means. And so we're going to take each point like this is negative 2, 1. So instead of plotting negative 2, 1, we're going to plot 1, negative 2. And instead of plotting 1, 2, negative 2, 3, we're going to plot 3, negative 2. And instead of plotting 1, 2, 3, 4, negative 4, negative 2, we're going to plot not negative 4, negative 2, but negative 2, negative 4. That's where P will go. And then last is our I. 1, 2, 3, 4, 5, negative 1. We're not going to plot negative 5, negative 1. We're going to plot negative 1, negative 5. And that is where I is going to go. Make our shapes. So notice, if I take this and I reflect it over the diagonal, which is another way of saying y equals x, this is what. So we're going to do something called a composite transformation, and we forgot to specify whether we're going clockwise or counterclockwise. So for number 7, assume you're going clockwise, and for number 8, assume you're going counterclockwise. So they should always tell you which direction, because that's important. So we're going to do more than one transformation. That's called a composite transformation. So first we're going to rotate 180 degrees about the origin. This is the origin right here. The way I remember it is when you go 180 degrees, the x and the y stay the same values, they just change signs. And what really helps me is remembering that this side is positive, positive. This side is negative, positive. And what I mean by that is you go left and then up to get to this quadrant. This one is always negative, negative. And over here, x is positive, y is negative. So there are rules for these, but I don't have them memorized. So let's start with the point I. Now I, if you're going 180 degrees, it's going to end up over here. So wait, this is clockwise. So I is going to go up here for 90, over here for 180. So the point I is 1, 2, 3, 1, 2. It's going to be negative 3, negative 2. So when it ends up over here, it's going to be 1, 2, 3, 1, 2. And that is going to be the point I. I went ahead and added the coordinates because I thought I would make it easier. So like E is negative 4, negative 3. So it's going to go 180 degrees. It's going to end up over here because that's 90, that's 90. But instead of negative 4, negative 3, everything up here is positive. So it's going to be positive 4, positive 3. And that is going to be point E, the image of E. And now down here, Q, if you go 180 degrees clockwise, it's going to end up over here. So it's going to be negative positive. So this is going to be negative 2, positive 4. 1, 2, 3, 4. And that's going to be Q. And then X, it's going to go 180 degrees, so it's going to go 90, 180, so it's going to end up staying on the y-axis. So instead of 0, negative 5, it's going to be 0, positive 5. We make our graph, and I should make sure I label this as X, the image of X. Make my new graph. So notice, one thing you should ask yourself, does it look the same? So does that look like it's the same? And I was almost about to say no, but it's because my coordinates are a little bit bigger. So if I turn this 180 degrees, would it look like that? Just to double check my work, and I believe so. So after looking over this, we realized that I is in the wrong spot because this is negative 4, negative 2. So this should be 1, 2, 3, 4, 1, 2. I should be right here. So I'm going to go ahead and get rid of this, this, and this. And I'm going to plot the correct point this time. So the correct point would be 4, 2. 1, 2, 3, 4, 1, 2. So now when I make my shape, and how did we find this mistake? We spent just a second to say, if I rotated this 180 degrees, would it look like that? And we decided no. So we went and checked our work, and we found that we made a small little mistake. After looking over this more, I noticed that these are not negative 4 over. It's 1, 2, 3 over. So this should say negative 3. And that should say negative 3. Which basically will just move this over 1, so it'll be 3, 2. And that will be I. And then E will be 3, 3. There's E. So I could go ahead and erase this now. And now this should be the right shape. So now that alright, so this one's a little different. We're going to go 90 degrees counterclockwise. So let me think, clockwise is this way. So counter is going to be the other way. So all of this is going to go from here to this quadrant, which is nice because everything's positive over here. I don't need to write that again. I can just go look over here. Everything's going to change to positive. So I start off with my 2, 0. Start off with my 2, 0. And what happens is when you're going 90 degrees, the X and the Y swap. So it's going to be 0, 2. So it's going to go 0, 2. So this one's going to go there. So that's V. The image of V. And then J is 1, negative 1. You swap the 1 and the 1, you still get 1 and 1. And because we're going to this quadrant, everything's positive. So it's still going to be 1, 1. So that's where J is going to be. Here, 4, negative 3. So just ignore the signs in rotation. So you change the 4 into 3 places, you get 3, 4. And everything's positive, so it's going to stay 3, 4. And that is where point R is going to go, the image of R. Now Y is 5, negative 3. Again, ignore the signs. Keep in mind everything's positive up here. When you go 90 degrees, the 5 and the 3 switch, so it becomes 3, 5. There's 3, 5 right there. And that is going to be Y. And then I should move R down a little bit. Now let's see what we get. So it's going to go from here to here. There to there. Straight up and down. And then I'm going to ask myself, does that look like it is rotated 90 degrees? And looking at it, it looks good to me. And then just so we know, we decided to rotate about the origin and not the point -1, -2. So I would just ignore this part right here and just do around the origin. We made the problem a little bit simpler. So imagine this said rotate 90 degrees counterclockwise about the origin. Don't worry about the points. Okay, but when you're in future math classes, you'll learn how to do that. All right, so number 9, find the lines of symmetry. And so I noticed that if I were to go from this corner to this corner, and I were to flip it over this line, they would be the same. Another word for that is reflection. I also noticed that there's a horizontal one. So if I reflected it this way, those would be the same. Now let me think if there would be any other line. Other ones would be, and I'll do my best to draw this, if you went this way, so like right down the middle, through the middle. If you were to fold over that line, you would get the same, and same thing for here. If you were to fold that way, you would have line of symmetry. So I found 4 lines of symmetry. I don't see any others. And now there's the word called degree. So we found the lines of symmetry. And now we're going to talk about degrees of rotation. So if I started off at this point here, and you were to rotate it, it would end up over here and it would look the same. Then it would end up over here, and then over here, and then back to itself. So we just found that the order of rotation is 4. And then how many degrees would that be? You just take 360 divided by the order. So we would have 360 divided by 4 equals 90 degree rotation. So what we found is for every 90 degrees, the image ends up back on itself. That's what we just found. Now the next one, how many lines of symmetry? This is going to be